So, in the last lecture we have seen how we can write a program to find out whether it is prime or not. Now, this program that you see that we had discussed in the last class will certainly give us correct result. Now, our job is not only to write a correct program, it is also very stimulating intellectually to think of how we can make it a more efficient program. Often the program can be correct, but it is not very efficient. What do I mean by this efficiency? Say, if we look at this program, and again I take the earlier example, that suppose I have my n is 13. Okay. Now, and I start with the value of I to be 2, I is 2 and n is 13. And since it is prime, I am checking this condition time and again, and since this is prime number, how many times it will never come here, it will never succeed. So, I will have to carry on this loop, and ultimately when I exhaust all the possibilities, then only I will come to this point. So, how many times do I have to do this? Let us see. I am starting with 2, checking once, then start incrementing and making it 3, then 4, then testing with 5, then testing with 6, testing with 7, testing with 8, testing with 9, 10, 11, 12. So, how many times did I check it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. I had checked it with 11 times. Now, do I really need to check it with 11 times? If you think a little bit, if this number is n, then I need not check it, and I am starting with 2. So, n minus 2 times I am checking, right. Do I really need to check n minus 2 times? If I do not find it divisible by within square root of n times. So, square root of 13 as an integer, what would it be? 13 would be 3 point something, right. So, 4 times within 4, if it is not divisible, it will not be divisible by the future numbers also, right. So, if I just apply this knowledge that if it is not divisible within square root of n, then it will not be divisible later, I can make this program much more efficient. So, now let us go to another example. This is again finding the sum of the digits of a number. Now, this one we did not do, sum of the digits of a number. What is meant by this? Suppose I have got a number 123. Sum of the digits of a number means 1 plus 2 plus 3, 6. If my number is 243, then the sum of the digits will be 2 plus 4 plus 3, 6 and 3, 9. Okay. This is what I want to find out. So, how do you go about doing that? How do I find out the digits? Say 1, 2, 3, from there, how do I extract out 1, 2 and 3? Just think over, if I have got 123 and I divide it by 10, I will get a quotient 12 and a remainder. So, the remainder is 1 digit. Now, I take the quotient, divide it by 10. I will get a remainder, a quotient and a remainder. The remainder is another digit, and then I go on till it is the number is not equal to 0. So, next I take 1 and divide it by 10, the quotient is 0 and the remainder is 1. So, you see I have got all the digits from the right hand side one after another, right. So, I can add them. Okay. That is my basic way. So, let us keep it on the side and see what we have done in this program. I have got a number n. Now, this number that has been given initially 123, I do not need to preserve that number. So, I can play with that, and I have to make a sum of this, right, 1, 2 and 3. So, I keep a sum to be initially 0. I keep a variable sum which is initialized to 0, as we saw in the earlier examples, and sum is also an integer. Then I read the number, that is say 123 has come. Now, while the number n, that is 123 is not 0, then I add n modulus 10. N modulus 10 will give me what? The remainder 3, and add it to the sum. So, my sum now becomes 3, and then I want to find out this thing also. I make my n to be n divided by 10. Now, this operation gives you the quotient, right. This operation gives you the remainder. So, I get n by 10 means now 12, and I go back to this loop. I check that 12 is not 0. So, I will again do that. Sum will be sum, what was that? 3 plus n modulus 10. So, I again divide it by 10 and take the remainder, and that remainder is added sum plus this. So, 3 plus 2 will be 5, and then I divide n by 10. So, now I find out 1. Still I go back, 1 is not, I go back actually here, 1 is not 0, sure. So, I again divide it by, I take the remainder, divide it by 10 and take the remainder. So, the remainder is 1, I add it with the sum. So, it will be 6, and then I find the quotient, and that is 0. I go back again here and find that n is not equal to 0, condition is not true. So, I come out of the loop and I apply this printf statement. What is the printf statement doing? The sum of digits of the given number, I cannot say given number n because n has already changed. I will come to that in a moment. Now, is sum. Okay, so, I have got the sum. So, this is another example of a while loop. Now, my question is, if you have understood it, I want the output to come as printf the sum of digits of the number 123 is 6. How can I do? What modification should I do in this program? What I want to be printed is the sum of digits of 123 is 6. What should I modify? Of course, I should modify this statement. This statement should be the sum of the digits of the number %d is %d, and here before sum what should I do? my n that was provided by the user has already been destroyed in this loop. So, what, because every time I am dividing it by 10 and making a new number, 123 is becoming 12 and then it is becoming 1, then it is becoming 0. So, I have to save it somewhere, this 123. So, what I can do here, after this reading this, I can save it in another variable num as n, and here I will put num comma. Now, because I am destroying n here, but I am not touching num. So, num will remain intact. Only another thing that I have to do, I have to add this num here. I must declare it num as an integer, otherwise it will give you syntax error. All right. So, this is another nice example of while, using which we can find the number of digits, the sum of the number of digits of a number, sum of the digits of a number, right. With that, we move to another example, decimal to binary conversion. Some of you may know it, and some of you may not be very conversant with that. We know that we have got the binary number system where the base is 2. So, everything is expressed using zeros and 1. So, if I have a binary digit decimal digit 4, its binary equivalent is 100. If we have 5, then it is 101. If it is 1, then it is 001 or just 1. If it is 2, it is 010, like that. The question is that given a decimal digit, how can I convert it to binary? What is the algorithm? The algorithm is something like this. Let us take the number 4 and I want to find out what is the binary equivalent of this. The algorithm goes like this. I first divide it by 2, because 2 is the base of any binary system. I divide it by 2. So, I get the quotient as 2 and remainder as 0. Okay. Next, I divide it again by 2. So, my quotient is 1 and remainder is 0. Next, I divide it again by 2. My quotient is 0 and remainder is 1. So, I go on dividing till I get a quotient to be 0, and I have remembered all the remainders that I got. Now, I can get the binary if I did it in this direction. So, it is 1 0 0. All right. Let us take another example. Suppose I want to have the number 15. Now, what is the binary of 15? To understand that, let us look at the weights of the different positions in binary. This one is with 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. That means, this is 8, 4, 2, 1. Now, 15 if I have to have, I must have a 1 here and 7 more. So, 1 here, 8 and 4, 12, and 1 here, 12, 13, 14 and 15. All these should be 1. Okay. So, can we find this out? Let us see. 15 I divide by 2. My quotient is 7 and remainder is 1. I again divide it by 2. My quotient is 3 and remainder is 1. I divide it by 2 again. My quotient is 1. remainder is 1, I divide it by 2 again, my quotient is 0 and the remainder is 1. I did it in this direction and we get 1 1 1 1. All right. Let us take another example. Again the weights of this system are 1, 2, 4, 8. Okay, 2 to the power 0, 2 to the power 1, 2 to the power 3, 2 to the power 2 to the power 2, 2 to the power 3. Okay. Next one will be 16 is 2 to the power 4. Now, let us take a number 23. What will be the binary representation of that? Let us see. Here 16 will be there, of course, it is greater than 16. So, 23, 16 and 6 and 7 more. So, this should be 0, I cannot put a 1 here because that will be 16 and 8 will be 24. So, 1 here, 20, this. So, my binary is 1 0 1 1 1. Let us try in our algorithm, divide it by 2, my quotient is 11, I have got a remainder 1, I divide by 2, my quotient is 5, remainder is 1, I divide by 2, quotient is 2, remainder is 1, divided by 2, it is 1 and 0 and divided by 2, it is 0 and 1. So, I reach a 0, I stop and this is the pattern 1 0 1 1 1, 1 0 1 1 1. All right. Now, let us see how this algorithm that we are talking of can be encoded in C program. You see here, I have declared one variable as des, that means the decimal number that I will be reading. So, I am reading that number here. Now, in the earlier example we did it while do. Now, here we that is also very interesting and known to us, that is finding the greatest common divisor of two numbers. Greatest common divisor of two numbers. What is the algorithm? The algorithm is shown here. Suppose I have got a number 45 and 12. I am to find out the greatest common divisor or the HCF of these two numbers. What I do is I divide the bigger number with the smaller number and get a remainder. You see, remainders are becoming so important. We come to the remainder and then if the remainder is not 0, I divide now the smaller number, this one, with the remainder and then I get again a remainder which is non-zero. Then I take the divisor, current divisor and divide it by this until we get 0. That is what we used to do in school, right. So, ultimately when I get 0, whatever is the divisor current divisor, that is our HCF or GCD. Okay. Here you see how the code is written. You just look at the code a little bit and try to understand it. A and B are two numbers. Now, I do not know as yet which one is smaller and which one is bigger. Here in our example, we can see one is 12, one is 45, but one is 12, one is 45, but I am going to try this. Here the computer does not know which one is 12, which one is 45 and I am taking another variable temp. I am reading the numbers A and B. Now, if A is greater than B, that means I am taking the greater number and moving that in temp. Out of this 12 and 45, which one is the greater number? 45. So, temps becomes 45 and B becomes A. B is the smaller number. So, 12 becomes A and B becomes temp. Now, you see I have written these three in one shot. So, let us see here what is happening. After this, first temp is 45, A is 12 and B is 45. Now, what I am doing here, I am keeping this temp. What I am doing here, I am dividing B by A. So, 45 is being divided by A 12 and I am checking the remainder. I am checking the remainder. The remainder is not 0, you can see that. Since it is not 0, I am taking temp to be the modulus of 12, sorry, B is what? B was 45, right. So, here B was 45 and A was 12 by this point. So, then and temp was 45, I try this, it is not 0. So, then I take this remainder 9 and again make that to be B. So, now B becomes 9 and A becomes the temp, which was this number, and I go on dividing this and I go on carrying out this loop till this becomes 0. As soon as this becomes 0, then I have got my GCD stored in A, because every time I am taking the A, in A I am storing the temp. And what is temp? Temp is, after I divide, I get the remainder and that I am storing in temp, and that temp is coming in A, all right, is being stored in A, and that is also copied in B, but in the next loop that is being divided by. So, here you are having 3, 9 and here 3. So, look at this iteration 1, here looking at this picture, first temp will become 9, B is 12 and A is 9. Next time temp is becoming 3, B is 9, this 9 and A is becoming 10. And whenever I find that B divided by A, this part is 0, remainder is 0, then that is my GCD, A is my GCD, I get the 3. There is another very interesting example of computing using this while loop, and repeatedly I am doing this till I find the remainder to be 0. So, there are many such nice examples, and we will give you some more during for assignments, which you will have to solve and get more you will get more confidence about it. Okay. So, next we will come to some of the pitfalls of loop and then move to something more useful, something very useful, that is the concept of arrays. Okay. Thank you.